Okay, Wafia, yes, your answer. What should happen to the reactivity of group 7 down the group?
Miss, the elements at the top of the group are going to be more reactive than the elements at the bottom, and this is because they're nonmetals, so it's
Hmm.
going to have a distinct difference from the group with the metals in it, which is group 1. So, and also how Jude explained that, the stuff to do with the electrons being, the valence shell being nearer to the
Hmm.
neutrons at
Okay.
for the elements at the top of the group.
Okay, Mariam, Jood, and Wafia, all three explained it right. All three explanations are correct. So I can just revise it again, repeat it again for other students. So basically, as we said in case of the group one was metals. Metals has to lose electron. So bigger the size, outer the shell is from the nucleus, away the shell is from the nucleus, easy it was to remove the electron. Okay, and size increases down the group because of the shell number. So it means as we go down the group for the metals, loss of electron was easy, so they were more reactive. Now, if we talk about non-metals, it has opposite trend. Non-metals has to gain electron. We know at the center we have protons and the electrons have the negative charge. So incoming electron that is going to add in the outer shell with the negative charge is going to be attracted because of this nucleus at the center, because of the protons at the center. So, smaller the size, more there will be attraction with the incoming. Bigger the size, like iodine, the size is bigger means this nucleus and incoming electron will have less attraction. So, here the addition of electron will not be easy. Okay, here it will be easy because of the smaller size and stronger attraction with the protons in the nucleus. And in case of the bigger size iodine, when we are trying to add one electron in the outer shell, there will be little less attraction because it is away from the nucleus. More shells are in between. So moving down the group, size is getting bigger, electron addition will be little harder, so reactivity of halogens group 7 decreases down the group. In your books, in your notes, maybe you have seen the explanation, or maybe you will see the explanation in two different ways. They can tell you that reactivity decreases down the group, or maybe in some books they will write the reactivity increases up the group. Same thing. You explain down the group or up the group. Trend you have to explain very well. Okay? Yes, Wafia.
Miss, we were discussing the physical properties of the halogens, right?
Yes.
And we said that at room temperature, chlorine is a gas.
Hmm.
So, you know how when you go to like swimming pools and stuff, people say that there's chlorine in the water. How exactly did they add chlorine to the water? Wouldn't
In
the
that
chlorine
case,
like react with
yeah,
it?
in that case, they are making it solution. Okay, this chlorine is gas at room temperature. We can change the temperature and make it liquid as well, condense it as well, make it solid as well. Okay, original state is gas, but we can make the liquid and solid as well. And that is not pure chlorine, basically, that is mixed with something else. Okay, so they can add in the form of some solution form in the form of solid as well to change the state by condensing it. Okay.
Yeah, but Miss, the water in the swimming pool isn't going to stay as water, right? It's going to change
Hmm.
into something else.
So gas can be dissolved in the water as well. For aquatic life in the water, we have oxygen gas dissolved in the water all the time. Even chlorine
No,
go to the
Miss,
oxygen gas form, it will remain dissolved in the water.
what I'm asking is,
Hmm.
oxygen is already, a part of the water since, hydrogen and oxygen, you get it.
Okay, I will.
But,
Hmm.
when you add chlorine to the water, then it changes into a different, liquid, right?
Hmm. Okay, basically, for you're confusing it with the oxygen. Oxygen is part of the water, but that oxygen is not helping the aquatic life to breathe. Oxygen is not separating from the water formula H2O to give it to the aquatic life. Oxygen is in the form of gas, dissolved in the water, water formula H2 is not going to break and give oxygen. Okay, it has the O in the formula, but that formula has nothing to do with the oxygen gas. Separate oxygen gas is dissolved in the water, and that is going to help the aquatic life to breathe. Same way, the cold drinks that you drink, the fizzy drinks, they have carbon dioxide dissolved in the water. Carbon dioxide bubbles will stay in the water. Okay, as soon as you just open the lid, open the cold drink, all the carbon dioxide can escape as well. Not all. Still, we have some bubbles inside. As soon as you just keep drinking for next few minutes, it will remain inside. Same way, the chlorine can also go to the water. We have this explanation in one of the chapter as well. And chlorine will mix with the water, make hypochlorite over there. Okay, so that thing we'll see as well what will happen, and little different story. Okay. Yes,
Yeah,
Vafia, any
miss,
other
because
question?
I searched it up. No,
Hmm.
miss, I just searched it up and it
Okay.
said
What you
that
got?
when the chlorine and water is mixed, it makes hypochlorous acid.
Yeah. So that is going to react with the water, dissolve with the water, and making something that will help chlorine to stay in the water. Okay. Yes, Samreen.
Miss, we said in the metals, like they're more shells, so they're easy to
Hmm.
lose electrons because they are far away from the nucleus, right?
Right.
And in the non-metals, like if there are more shells, I didn't get like how it is like because in the non-metals they
Hmm.
are gaining electrons.
In the non-metals, what we have to do? Loss of electron or gain of electron?
In non-metals, there's gain electrons.
Gain of electron. And metal was loss of electron. In case of the metals, let's say there is just one shell or two shell, metal has to lose electron. It will be hard to lose because it has more attraction with the nucleus. It will be hard to remove this electron which has more attraction. And if we take another metal with maybe more shells now, and we want to remove the outer electron from here, this will be easy to remove because it is not having very good attraction with the nucleus. So
Miss,
losing electron from the bigger size with more shell is easy because it is too away from the nucleus, weak attraction.
yes,
And
miss.
adding electron in the bigger size is hard because when electron is adding, it needs to create attraction with the nucleus. Bigger size means weak attraction will be created. So addition of electron will be hard in that case, and the addition of electron will be easy in case of the smaller size. I hope
So
your
miss,
question is clear. Mm-hmm.
if there are like more shells,
Hmm.
so the adding of electrons will be weak. I mean, the electrons that will be attached will be weak
Yes, definitely. More shells means electron addition will be little hard
because they are away from the nucleus, like
because they're away
far.
from the nucleus, weak attraction.
Okay, miss.
Okay. And addition of electron is telling us the reactivity. If electron addition is easy, more reactive. Electron addition will be hard, less reactive. For the metals, if electron removal is easy, more reactive. Electron removal is hard, less reactive.
So
Okay,
miss,
so
addition for the
Mhm.
electron, the adding of electrons, if it is easy, so that means like the the reactivity, it will
Is
be
more. Easy means more reactive.
more reactive, and if it is more, the addition is hard, so it will be less
Hmm.
reactive.
Yes, definitely.
Okay,
Okay,
miss.
so that is the reason they are getting electron more hardly as we move down the group because of the bigger size. So it means reactivity decreases down the group. Okay, so this whole explanation you can find here in the notes. So now we can move forward. Okay, iodine, as we said, iodine is going to be solid because it is gray-black solid at room temperature. But we can change this into other states as well by changing the temperature. So iodine is the only thing which is going to change color at every state. So when it is solid, it is going to be gray-black. As soon as we change the iodine to vapors form, it is going to be purple. If we mix it with water and make it liquid, it is going to be brown. So it has three different colors at three different states. Remember one thing, they did not say here melt it. They did not say that we can have solid iodine, gas iodine, and liquid iodine. They said if we mix it with water, then it is brown. Any idea? We have some examples in chemistry which just exist in two forms: solid, then directly changes to gas without going into liquid. Do you remember any example which is in the form of solid and then directly gas changes to gas, and what is the name of the process? Jute,
The process name is sublimation,
right? And any
and I
example
guess
you
like
remember?
ice
Dry
cubes, like
ice. Dry
the
ice.
hard
Dry ice. Dry ice,
dry ice.
guys. Dry ice is made up of, yes, Wafia,
Miss, it's made of carbon dioxide.
carbon dioxide. So one example we already did when we did about the sublimation process, and we have carbon dioxide in the form of solid. Then we say dry ice. It can directly change into gas form without changing into liquid. So that is sublimation process. And remember, iodine is second example that you can add in your list. Iodine exists in the form of solid, and if we try to change the state, it will directly change into gas state without changing into liquid. If we need it in the liquid form, we can just mix with water, make aqueous solution. Otherwise, we cannot melt it in the liquid state. So that's the reason they said over here that iodine is going to be gray black solid, purple color vapors. And if we try to mix it in the water, not melt, mix it in the water, make the aqueous solution, it is going to be colored. Okay, so let's move forward after that. Okay, now predicting the properties. Again, just like the group 1, they can ask you one of the property of one of the element from group 7 and ask you to predict the properties. So we can summarize that melting point, boiling point of halogens increases as you go down the group. And as we said, the density is increasing, gas, then liquid, then solid. So density increases, their melting boiling points also increases. Fluorine at the top is going to be the lowest, having lowest melting boiling points. And the acetylene at the end of the group is going to have highest melting and boiling points. Physical state become denser. At the start, fluorine is gas. At the end, the acetylene is going to be solid. Okay. Color is becoming darker. The starting one is going to be fluorine color is going, fluorine has no color, or you can say it's very light. Fluorine is somehow yellow, or sometimes it looks colorless, but light yellow color. And for chlorine, it is pale yellow color. And then color is becoming darker and darker as we move down. So acetylene at the end is going to be black. Iodine is gray black and acetylene is pure black. So color is becoming darker as we move down the group. Okay. So that's all about group 7 properties. We will see group 7 reactions as well. Before that, if you have any question till here, you can ask. Yes, Wafia.
Miss, does fluorine or fluorine have anything to do with fluoride that's in toothpaste?
Yes, it is. We said that we can say them halides, right? When they make the negative ions, we can say them halide. So if fluorine is going to make negative ion, F minus, that is known as fluoride. Cl is going to make negative ion, that is known as chloride, bromide, iodide, astatite, like this. So fluorine means F2, chlorine Cl2, when they are in the diatomic form. So if we say them fluoride, means we are talking about the negative ion now, halide ion now. So fluoride, chloride, bromide is the negative form of these halogens. Okay?
Miss,
Yes?
but then sometimes toothpaste gets ingested, but like it's not poisonous, so um
What again your question is?
Miss, it says here that halogens are poisonous. But
Hmm.
you said that fluoride and fluorine are directly related. So, but sometimes when you ingest toothpaste, you don't just
Hmm.
die. So,
No,
um,
no, no.
how
Chlorine, fluorine, they are present in the form of gas. If the gas is going to your lungs while you're breathing, that can be poisonous. Okay, liquid and solid has no direct link with the body unless you touch them, drink it, eat it, or whatever, any contact with it. But the gases, they are poisonous as well. Okay, so they are somehow poisonous. Chlorine is one of the poisonous gas as well. Okay. Any other question here? Yes, Samri.
Miss, I didn't understand Wafia's first question. What did she ask?
She basically said, I think, that fluorine and fluoride has any link or not, right?
So,
So,
Miss,
Wafia,
then
you
you
said the same. Mhm.
added,
I
then you
said
said
that
halide.
we have the formulas of halogens in the diatomic form F2Cl2 Br2 I2 when they are stable, when they are just gaining one electron or sharing the electron with other fluorine. 1F is sharing electron making F2, Cl2, Br2, I2, stable forms, diatomic forms, right? If we just
Mm.
take one fluorine or one chlorine and it has gained one electron, let's say, it is going to make negative anion. That anions are known as halide ions. Halide means whatever the name of the halogen is, give the name to the halide. Fluorine is giving the name to this F negative as fluoride. Chlorine is giving the
Mm.
name to this Cl as chloride. So fluoride ion, chloride ion, bromide ion like this.
Okay, Miss.
So when they're diatomic, we say simple fluorine, chlorine, bromine. But in case of the ions, we say them halide ions means halide is a general term for all. Fluoride, chloride, bromide is the separate name for all.
So, Miss, when they're ions, we call them fluoride, chloride.
Yes, we call them fluoride ion, bromide ion, like this. And when they're diatomic, we say simple fluorine, chlorine, bromine. Okay?
Okay, Miss.
Okay. Now we can move forward to their displacement reactions. Displacement reaction is also known as substitution reaction. Substitution means replacing. So you can see three different names in your books. Maybe displacement reaction, maybe replacement reaction, replace. They have the same meaning. Displace, replace, or substitute. So substitution reaction, displacement reaction, or replacement reaction has the same meaning. It means one of the halogen can come and replace or displace other halogen. In other words, let's say you have three friends in one group. Another friend from outer circle is coming and replacing one of you. So she can replace only if she's stronger, having more abilities, having more, you can say, connections, more friendly relationship, so that she can come and replace one of you. So
शुरू होगी क्लास
तो एक घंटे से शुरू
if
हुई
we
है।
already have
वो बंद हो
some
गई ये शुरू हो गई
halogens,
ये मिस है
yes, Nabila, what you
ये
said?
सामने आके पढ़ा रही है अरब में रहती है
Okay, I think the mic was unmute. Okay, so displacement reaction means one of the halogen can come and replace already present halogen. So the other halogen can come and replace only if the incoming halogen is going to be stronger than already present halogen, having more properties than already present halogen. So what we can say, a more reactive halogen can come and displace or replace the less reactive halogen. How it is going to replace? It is going to replace from the aqueous solution of its halide. Let me tell you one example here. Okay, chlorine and bromine. Chlorine is at the top of the group, having more reactivity. What we said, as we move down the group, the reactivity is going to decrease. So it means chlorine is at the top, bromine is under it. It means chlorine is going to be more stronger, more reactive. And yes, if chlorine is there, it can replace bromine, which is less reactive. Okay, we are going to take the aqueous solution of bromine so that we can remove bromine from this solution. So we can take any solution. Let's say we are taking KBr. A solution which contains bromine is known as bromine's aqueous solution. So KBr aqueous we are taking with chlorine in the form of diatomic. Now chlorine is more stronger. It can come and remove this bromine out and take its place, and this bromine will be separated from this pair, from this group. It will be out from this group. So what will happen? Cl is coming in. This is 2 kbr, means 2 Cls are needed if we want to make it balanced. So Cl2 having 2 Cls. 2 Cls are coming in becoming the part of the formula will be 2KCl now. And two BRs are removing from here and going into the Br2 form. Because when bromine will be separate, it is not going to be Br form, it is going to be diatomic Br2 form. Okay, so chlorine is coming and removing or replacing the less reactive bromine from its aqueous solution and taking its place. That is known as displacement reaction. How the question can come in the exam? They can directly ask you the equation, or maybe they can give you an equation and ask you if it's possible or not. Let me tell you one equation. Let's say we have 2KCl in the form of aqueous having Br2 in the form of aqueous, because all are in the solution so that they can replace each other easily. Okay. And the product that we have is 2KBr aqueous with Cl2 aqueous. Raise your hand and tell me, is this reaction possible or no? Can bromine come and replace this chlorine and do make these products here? Yes, Mariam.
I think yes.
Yes, Mariam. This reaction is possible or no?
Yeah, I think it can be.
It can be. Okay. Yes, Jude.
Miss, I think it's not possible because the reactivity of Cl is greater than Br, so how can it replace it?
Right. It is not possible. As we said, bromine is down. It means it is less reactive than chlorine. Bromine is weaker. A weaker cannot come and replace the stronger chlorine here. So this product is not going to form. This is not possible reaction. Okay, we can say this reaction is not going to proceed. This is the expected product that we wrote, but it is not possible in reality. Why? Because bromine is less reactive than chlorine. A less reactive bromine can never come and replace the more reactive chlorine over here. But opposite is possible. Opposite is already written here that chlorine can come and replace bromine. Bromine cannot come and replace chlorine here. Okay, yes, Samreen.
Miss, bromine is like Br, right? So why is
Hmm.
K? K is because if it is aqueous.
Yeah, we are taking its aqueous solution. See, if we want to replace it, it means we have to take it in the form of a group from where we have to replace. So we
Miss
are
K is
taking it again. Yes, Samreen?
Miss K is potassium then.
Is potassium, KBr, and ionic bond is here. From this ionic bond, we are replacing bromine adding chlorine. So if you want
Oh,
to
okay.
replace it, it means there should be something with the Br from which we are going to replace it. Okay, so we are
Yes, ma'am.
taking an ionic compound in the form of aqueous, chlorine in the aqueous, products are all aqueous, everything is in the solution
So
form.
miss, in a displacement reaction, we always take the aqueous solution.
Always aqueous, yes, always aqueous. For now,
And
for your grades
it
9 and
is
10.
having an ionic bonding, right?
Ionic bonding, yes. Metal and non-metal has ionic bonding, yes. So
I
more
understand.
reactive is coming and replacing the less reactive. Okay, now I have one more example and you will tell me, keeping in mind the reactivity of group 7, this equation. MgI2 plus bromine. Bromine is coming and replacing iodine here. Is this reaction possible or no? Tell me the explanation as well. Any new student now? We just have 3-4 participants who are just participating again and again. And remember, I will give the bonus marks to those who are participating. Yes, Varif. Hmm.
Yes, miss. It can
Hmm.
replace because bromine is
Hmm.
it can replace because the bromine is not less reactive than
Right. Not less, or in other words, it's more reactive. So we have fluorine, chlorine, bromine, iodine under bromine. Okay. Yes, Mariam, you can also tell the
yes.
explanation. Mm-hmm.
Yes, I have a question. Yes.
Question is, this reaction is possible or no? Can bromine come and replace this iodine to make MgBr2 or no?
Yeah, it can be, but I have a question. The upper
Okay, you have a question. Yes,
question.
Mariam. Your question. Hmm.
يعني it can't be calcium can be in يعني 2 calcium bromine plus calcium plus chlorine it can be but bromine can't replace the chlorine.
Bromine cannot replace the chlorine, yes, because bromine is less reactive than chlorine.
Mm. يعني but we can have the equation 2 calcium bromine plus
No,
chlorine.
we cannot have the equation. This is the supposed equation I have written. I said, okay, if it will replace, this is going to be the product. So we have to see, is it possible or no? We can write any
يعني it
equation.
can't
Maybe in
replace
reality, it is not possible.
يعني it can't
Okay?
be replaced but and also it can't be in reality.
It cannot be in reality. In reality, this is not a possible reaction. So this equation is wrong. Okay? If we are writing Br2 is replacing the
Okay.
chlorine, it means it's a wrong equation. It is not possible in reality.
No, not replacing. I mean it can be like given bromine plus chlorine. 2
Barom,
calcium bromine plus chlorine.
no, Mariam, your question is not clear to me. Again,
يعني miss يعني like it can be written as the notes saying.
it will not be written this way. See, if we have 2 KCl plus Br2, this is not possible that bromine come and replace. What will happen? The reactants will remain reactants. They will not change to anything. 2 KCl will remain 2 KCl. Br2 will remain Br2 in that case. Okay, it will not go to any other form. It will not change. It will not replace it. So it means these reactants will remain in the solution. They will not change to any other product. Okay.
Okay. Okay, thank
So
you,
this
miss.
equation will not happen. Reactants will remain there. No products will form at the end. Okay. So this is going to be possible because yes, iodine is under the bromine. Iodine is less reactive than bromine. So bromine, more reactive, can come and replace the iodine over here. Okay. Okay, so we can move forward and now we can have this table. Sometimes they can ask you to fill this kind of the table as well, whatever reaction is possible or no. So we have chlorine and this thing has to come and replace this side. Okay, we have chlorine. Chlorine has to come and replace chlorine in KCl, same thing. Chlorine replace chlorine, like no reaction. We are not going to see this replacement, so cross. Bromine can come and replace chlorine in the KCl? No, because bromine is going to be less reactive. You can, whenever you have this kind of the reaction, go to the periodic table and see the sequence. We have fluorine, chlorine, bromine, iodine, like this. Top means it is going to be more reactive. The last one means the less reactive one. So bromine is under the chlorine. So it means bromine cannot go and replace chlorine. So no reaction. Iodine is also under the chlorine. So iodine cannot go and replace the chlorine. So no reaction. Now we are going to replace this chlorine will go and can replace the bromine or no. We have to see this. So chlorine is above the bromine. So yes, it can go and replace it. So it will replace the reaction. It will replace the bromine and there will be some changes in the reaction color as well. How? When it is KBr, it has a different color. When it will replace and make KCl. So what will happen? KBr plus Cl2 will make KCl, 2 will come at the start, plus Br2, right? Before that, the solution was having a different color. Now, when it will make the product, it will make the bromine as well. And the bromine is going to be orange color. So yellowish orange color is going to produce at the end of the solution because at the start there was chlorine only having pale yellow color. But now the color changes to the brown or orange or yellowish orange color. Okay, so color change will happen as well, and they can ask in the exam what color will be the final color after displacement reaction. Okay, then bromine displacement, no, it's the same thing. Iodine cannot go and replace bromine, so no reaction. Then chlorine with iodine. Chlorine can go and replace iodine over here because iodine is under the chlorine. So yes, reaction will happen. And what will be the color at the end? When this reaction will happen, it will be 2Ki with chlorine giving us 2KCl with iodine in the aqueous form. So we just said above that when iodine is in the aqueous form, it's written here as well, it is going to be brown in color. So the final color, because of this iodine, will be there in the solution, and that will be brown color. Okay. Same bromine can come and it can also replace the iodine. And same way we will be having 2 kBr and I2 as the product here. So again, brown color of iodine we can see. Then iodine, no replacement. It's the same thing. Okay. Yes, Mariam.
Miss, actually, I have a question.
Hmm.
Chlorine must be aqueous. So,
All should be
iodine,
Hmm.
all should be aqueous.
All should be aqueous. When we are doing the replacement reaction, we are going to take all the reactants aqueous, products will also be aqueous. All should be in the aqueous state, mixed in water. Okay. Because chlorine is gases, bromine is liquid, iodine is solid. If we take them in solid, liquid, gas form, how they can react and replace something? So we are taking all
Mm.
in the same state, all in the aqueous state, so that they can easily show us some displacement reaction. Okay.
Mm.
Okay.
But Miss, here it's not written that it's aqueous or not.
It will be aqueous, yes, yes. All the reactants aqueous, all the products will be aqueous as well. And we are talking about aqueous color here. Bromine, actually in the form of solid, it is gray-black. The iodine, sorry, iodine is
Mm.
gray-black, but in the form of aqueous, it is brown. So we are telling the aqueous color here because all the products formed over here will be aqueous.
Oh, okay. Thank you so much.
No problem. Okay. After that, we can move towards the transition elements. If you see the periodic table, we have discussed a little about group 1 and 2 already. Group 3 till group 8 is also known as group 0, the noble gases. We have a little discussion on them as well. Now the 10 groups at the center in between group number 2 and group number 3, we have 10 columns at the center. These blue that you can see over here. They are known as transition elements and all are metals. So we also say them transition metals. Why we say the word transition? Transition means in between. So they are present at the center of the periodic table. Right side here we have some metals and then non-metals. Left side we have metals. So in between metals, non-metals, we have a whole block of transition metals with 10 groups total. 10 columns are there, you will remember them. Okay, not remembering the name, just remember there are 10 columns over here, 10 groups over here, and this block is known as transition metals. Yes, Varif.
Miss, it's group 1 and 2 are metals. Why are they not from the transition metals?
Okay, we will talk about this as well. Why group 1, 2, or even 3, they are not included in the transition metals. Transition metals have some different properties as compared to group 1, 2 metals or group 3 metals. So they have some different properties from other groups. So they are placed separately, and these 10 together are known as transition. So let's see their properties, how they are different from group 1 and 2. So your question is very good, that why group 1, 2 is not transition. They are also metals because they have some different properties. So let's see the properties now. So some properties of the transition elements as they are metals. So some properties of transition metals and group 1, 2 metal will be same, but some properties will be different as well. So they are very hard and strong metals. This is something different. We said group 1 are going to be very soft metals. Even group 2 are not very hard. They are also soft. We can cut group 1, 2 metals with the help of knife. They are just soft like butter. But transition metals are hard. So this is one of the difference as well. Yes, Mariam, any question?
Yes, Miss, but they are more than 10.
They have what again?
They are more than 10. You said they are 10, 10 block. They are more than 10.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The blue ones
Oh,
only.
just the row.
Yeah,
Oh,
just the blue ones. In between group 2 and 3, the center having these 10 groups at the center, they are basically transition, total 10 only. Okay. Okay, come
Yeah,
back.
they are 10 groups, not 10 elements. Oh, okay, okay.
No, 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 10 groups, not elements. These elements which are in these 10 groups are known as transition elements or transition metals, not 10
Okay.
elements. Okay, groups are 10. Okay, so they are hard and strong metals. They are good conductor of heat and electricity, just like normal metals. Because they are metals, so they should be good conductor of heat and electricity, as they have a lot of free electrons moving. Sea of free electrons will be there. They have very high melting and boiling points as well. That is something different because the melting points of the group 1 was low. They have high density. They are highly dense metals. Group 1 was having low densities. So these are some differences. For example, the melting point of titanium. Titanium is one of the transition metal is 1688. If we compare this melting point with the group 1 metal, group 1 can melt at only 63.5. Potassium. Potassium from the group 1 can melt at 63, but the titanium, which is one of the transition metal, it melts at 1688. No need to remember these temperatures, but you can compare them, you can check them. Okay, so it is slightly 63 means little slightly warmer than cup of hot chocolate. So if you have like little higher temperature at room 63 something, potassium will melt, but nothing will happen to the titanium, which is transition metal. Okay, then the next property is transition metals form colored compounds and they have more than one oxidation state. I will talk about this oxidation state as well. What does mean by oxidation state? And having more than one oxidation state, what does mean by this?